Hi guys, so I just wanted to conceptually talk about friction because this is the last force that we're going to focus on in this particular chapter. On Monday we're going to do some more force problems with friction, and then Tuesday we'll also have some more example or practice problems with those, and then on Wednesday I'm thinking that I would like us to maybe do some practice, maybe multiple choice, also some practice possible FRQ questions. Thursday will be your multiple choice test over chapter 5, and then Friday we're going to do a lab. So we'll have practice problems Monday, Tuesday, Wednesday, a test over chapter 5 on Thursday, and then a lab on Friday. On Monday through Wednesday, you should be prepared for any quiz any day, just so you are aware. And then remember that your videos are supposed to be due on that following Monday, and we'll watch some of those in class then on Monday as well. Okay, so in terms of friction, just conceptually, let's get a definition of friction. We know that when an object is in motion, either on a surface or through some type of medium like air or water, for example, there's a resistance to motion, to an object moving. And that's because that object is simply interacting with the environment or its surroundings. So because it's interacting with some other type of medium, whether it be a surface, whether it be water, whether it be air, we're always going to have some type of resistance. So we call this resistance to motion a force of friction. So the force of friction is always going to oppose the direction of motion. Now, friction is really the force that enables us to walk or run or to even drive a car. So we have a woman here, and she got her awesome kicks on. And we know that she's going to exert some type of force on the ground by her foot. So she's exerting some force on the ground because of her foot. And I know that the reason that she can proceed forward or move forward is because there's a frictional force that will be exerted on her foot by the ground. Because technically her force would be pushing backward, but that ground is exerting a frictional force. It's opposing that motion by exerting a force back on her foot. So because of this, we are able to walk, which is pretty cool. Okay, so why do we have friction? A long time ago, we thought that friction arises because of surface irregularities, because if we look microscopically at surfaces, they're really not so smooth. They actually have like jagged peaks or jagged edges on the microscopic level. But actually we find that really that doesn't have quite a bit to do with it. Instead, we contribute friction to local adhesion. So really friction happens because of local adhesion. So when surfaces are pressed together, we can get something called spot welding or local welding or bonding. And that occurs because we have a few small patches where there's some large asperities that make contact with one another. So when two surfaces are in contact, we can kind of have this like local bonding, or they called spot welds, where I have some type of an attraction. That spot welds, those local adhesions, are mostly contributed to some type of electrical interaction between atoms and molecules. So it's really because we have some type of maybe Coulombic attraction going on. I have some type of electrical attraction. And to overcome this local adhesion, we're going to need a force that's great enough to pull apart those bonded regions. So friction is really happening not because of surface irregularities, but because of some type of local adhesion. We have some different types of friction. The two that we're going to focus on in this chapter are static friction and then kinetic friction. Rolling friction we'll get into in a couple more chapters. And we're thinking about this just in terms of solids here. So static friction is when the frictional force is large enough to prevent motion. Kinetic friction is when two surfaces are simply sliding along one another. We have equations that go along with each of these things, and we observe that the frictional force is proportional to normal force. So my capital N here is just representative of the normal force. This Fs is going to represent static friction, and if I wanted to represent kinetic friction, we're going to represent that Fk. So I have the static friction is going to be less than or equal to this mu s. That's going to represent the coefficient of static friction. So mu s just represents coefficient of static friction. And that's a number that we have calculated for particular objects, for specific materials. So it's going to be the coefficient of static friction times the normal, and that's going to give us our static friction. Now, the reason that this is going to be less than or equal to the coefficient of static friction times the normal is because static friction could be any value from 0 to some maximum value where I actually get that object into motion. So because it could be a wide range, we can't just say that it's equal to. It's only going to be equal to when I have reached that maximum value. So the static frictional force may not have its maximum value. So that's why it could be a range, which is how we designate it up here. But once it reaches that value, once it reaches that maximum value to overcome static friction and now become kinetic friction, that's when we would get that to be equal to the coefficient of static friction times the normal force. For kinetic friction, we just simply have kinetic friction is equaling mu k times the normal, whereas mu k is just representative of the coefficient of kinetic friction. Typically, coefficients of kinetic friction are smaller than the coefficient of static friction. So this figure is just illustrating that when we have some type of applied force and we increase that applied force, we can see that our static frictional force is also increasing in comparison. So if I'm applying some type of force, I'm increasing that applied force. This is my frictional force on the y-axis, applied force here on my x-axis. So as I'm applying some type of force, I'm seeing that that static frictional force is also increasing. Once I reach that maximum value, once I reach that threshold, I'm going to get kinetic friction. And once I get kinetic friction, if I continue to apply the same amount of force, I'm going to just see that that kinetic friction there can continue on. But I have to have enough force that's added to try to overcome that static frictional force. So I can see here in my diagram that I have a woman trying to push a file cabinet by herself, but then I have static friction also opposing that. She's trying to push it, cabinet's pushing back. In terms though, she may not be strong enough then to push it by herself, so she can't overcome that static frictional force. She has another guy come in to try to apply some more force, but static frictional force is going to become larger based on that applied force, still doesn't want to move. It's not until they apply even more force to make that accelerate that now I've overcome static friction, and now that friction has become kinetic friction. And so our coefficients of friction are going to depend on the materials involved. So mu s, mu k are going to be different based on the different types of materials that we're going to see in our problems. So this is just a table. We'll reference this table possibly for the most part in your questions. They will give you the static coefficient, or they'll give you the coefficient of kinetic friction, or I may actually have you solve for one of those things in a problem. On Monday, we are going to start with this example here in class, and we'll do several examples with problems of friction if we have time. We'll go over those homework questions that you turned in on Friday. If not, I will post an answer key. I'll give you back your problems on Monday, and I'll post an answer key on your blog so you can compare to see maybe what you did wrong. Since your multiple choice test is on Thursday, I want to offer a review session on Wednesday night. So if you would like to come to the Deerfield Township Starbucks on Wednesday night, we'll probably go from like 6 until maybe like 7 or 7:30. So I'll be there for about an hour to an hour and a half. If you want to come, ask questions about homework problems, we could do some extra practice problems, but I will offer you guys that. So Wednesday night, 6 to 7 or 6 to 7:30, just depending on who's there and who shows up. So if you guys want to do that, that's there. Like I said, test on Thursday, and I will see you guys on Monday. I hope you have a really great weekend. Bye.